probe meant to reach Mars went silent, then burned up. A single unit conversion error turned a 14 billion yen spacecraft into space dust. In 1999, NASA's Mars Climate Orbiter, a colossal investment of $125 million, approximately 14 billion Japanese yen, disintegrated before ever reaching Mars. Yet, in reality, this failure stemmed from a structural cause, a recurring pitfall in modern organizations that anyone can fall into. Why did humanity repeat such fundamental mistakes even far from Earth? What was the true story behind it? In this video, we will explain why a simple mistake went unprevented, the darkness of inter-organizational communication, and the lessons for modern project management. Now, let's delve into the complete story of the Mars Climate Orbiter's collapse. The main feature also provides a detailed explanation of how this failure impacted subsequent space development. In the late 1990s, NASA was poised to usher in a new era of Mars exploration. It was a grand plan to unlock the planet's mysteries. Mars was thought to have once harbored abundant water, and the search for traces of life was one of humanity's greatest dreams. As part of the Mars Surveyor program, this probe was entrusted with the mission to thoroughly investigate Mars climate change and water history. The Mars Climate Orbiter, commonly known as MCO, was designed to observe atmospheric conditions from Mars' orbit and record changes in the surface topography. Equipped with state-of-the-art sensors and a high-resolution camera, it was expected to deliver more detailed data than any previous probe. Scientists believed that the data sent by MCO would help unravel the process by which Mars became its current dry state. And it was also meant to be a crucial stepping stone toward the realization of future crewed missions to Mars. The world's attention was focused on this historic mission. It held humanity's hope for pioneering the frontiers of space. The development of MCO was steadily progressing, led by NASA's Jet Propulsion Laboratory, or JPL, and Lockheed Martin. On December 11, 1998, MCO, carried aboard an Atlas IAS rocket, was launched into the night sky from Cape Canaveral, Florida. The successful launch was met with jubilation by those involved. The probe smoothly exited Earth's gravitational field and began its approximately 9-month journey to Mars. Throughout its voyage, MCO maintained regular communication with Earth, reporting its healthy status. Everything seemed to be proceeding according to plan. The probe traveled through space at speeds of several kilometers per second, with the precision to accurately target Mars tens of thousands of kilometers away. At this point, several minor orbital corrections were made, but these were standard procedures in space exploration and were not considered problematic. Expectations soared, and the countdown to Mars arrival began. Day after day, the media reported MCO's latest updates, fueling people's dreams of space. The day humanity would again approach the mysteries of Mars was finally imminent. Up until this point, everything had been smooth sailing. On September 23, 1999, MCO made its closest approach to Mars and began its orbital insertion maneuver. However, the probe failed to appear at its planned altitude. Subsequent investigations revealed a shocking truth. Lockheed Martin had calculated the thruster's force in pound-seconds. However, NASA's JPL software interpreted that data as being input in newton-seconds, a metric unit. This confusion of unit systems caused a fatal error in MCO's orbital calculations. The numerical difference between pounds and newtons is approximately 4.45 times. The probe was attempting to enter the Martian atmosphere at an altitude of approximately 57 kilometers, far lower than the planned 140 to 160 kilometers. Typically, such a significant discrepancy in unit systems should have been discovered during the numerous tests and review processes. However, there had been no clear agreement or verification between JPL and Lockheed Martin regarding the unit systems each was using. And here, a trap unnoticed by anyone, silently opened its jaws. Behind this unbelievable error lay complex inter-organizational communication and stringent budget and schedule constraints. The project was divided, and the thruster data provided by Lockheed Martin was passed directly to JPL's navigation team. Each team was confident in the accuracy of its own area of responsibility, but they neglected to thoroughly verify each other's data processing methods. Regular review meetings were held, but this fundamental unit system inconsistency had slipped through the detailed checklists. Furthermore, multiple Mars missions progressing concurrently dispersed personnel and resources, hindering concentration on individual projects. During its months-long voyage, MCO's orbit had gradually begun to deviate, but this was attributed to other factors and not taken seriously. Everyone believed in success, and amidst the hectic daily grind, the invisible risk of verifying the most fundamental assumptions was left unaddressed. As a result, everyone fell into the trap of collective thinking, believing someone else must be checking, and the fatal error progressed undetected. September 23, 1999, the final approach to Mars. MCO moved behind Mars and began its retrothrust for orbital insertion. However, due to the unit system error, MCO plunged into the Martian atmosphere at a much lower altitude than calculated, just 57 kilometers. The probe was exposed to intense frictional heating from a much denser atmosphere than its design anticipated. Communication suddenly ceased. In Earth's control room, silence fell the moment MCO's signal was lost. Within minutes, everyone realized the worst. The Mars Climate Orbiter disintegrated and burned up in Mars' unforgiving atmosphere, and the approximately 14 billion yen probe became cosmic dust. A single unit conversion error instantly erased humanity's grand dream, along with immense effort and expense. This failure highlighted the crucial importance of thorough communication between different teams and organizations and verifying fundamental assumptions. It left a universal lesson. Even in highly advanced technical projects, neglecting simple human verification tasks can lead to total collapse. The tragedy of the Mars Climate Orbiter provides a clear answer to the question: why couldn't a simple mistake be prevented? It was due to organizational divides and a lack of communication. This case highlights the ever-present risks in all modern projects that involve collaboration between different departments or partner companies. Neglecting to share just one unit system, just one fundamental assumption, literally turned a 14 billion yen probe into ashes. There must be a significant difference in decision-making quality between those aware of this failure and those who are not. The importance of sharing information across organizational boundaries and rigorously adhering to fundamentals. This lesson should be deeply imprinted in our work and lives. If you found this video helpful, please subscribe and give it a like. We introduce a history of failure every day. Next time, we will continue to explore wisdom that can be applied today, drawn from the grand mistakes humanity has repeated.
この失敗は歴史のほんの1ページ。世界にはまだ語られていない失敗が数多くあります。失敗の歴史をチャンネル登録して次の物語もぜひご覧ください。